Okay, assalamu alaikum everybody. Welcome to our fourth workshop of this academic calendar. We've got numeracy workshop today. So we'll begin with a little task. So on your tables, you'll have A3 sheet of paper with 4 quadrants, 4 sections. So can we please ask you guys to split that into these 4 headings and discuss with your partner what does home learning look like, especially for maths. Okay? What is going well, so things that you're doing at home, things that you're proud of, things that you think your children are engaging with and they're going really well. If you have any concerns, and again, specific to teaching of maths, and are there things that can be improved? What can be better? If you recognize any weaknesses, anything that needs improvement, if you could just write those down, please. Where it says what is going well, feel free to go through anything else other than maths if you want to. Well, that's it. Let's get started. If you have any questions, let me know.
Have you got paper?
Everyone's got paper. Okay, if I can stop you all there. Thank you very much. Can I, before I collect these in, can we have, oh yeah, you can keep it, add things to it as and when you remember. Can I get 1 or 2 examples from any of them from people? We'll start with Waleed, sitting in the front.
So in terms of what does home learning look like for maths, regularity and a bit of consistency as best as possible. So trying to do it quite regular. The element of repetition in terms of what we're doing with him at home, another kind of like style of certain things. So he's doing a piece around minute maths, which he enjoys doing. It's a bit of a timed thing to work out your mental maths. And then reviewing work from the grower and supplementing it with resources if we're struggling with that as well.
Okay, that's great. Thank you. Asfar, anything you put down from any of the sections?
So pretty easy, we go through the concepts he has learned, but already he does worksheets himself. We check and help him if he's done anything wrong. You find the worded problems, you know, like the ones in the sentences and stuff, a bit slightly harder than normal, so we have to go through a bit.
That's normal.
It's not nice.
And does this happen daily? Like
Yeah. So straight after we come back from Growery,
Okay.
we do so when he still has energy.
Brilliant. Ahmed, you have something for you?
So slight difference to what was mentioned. We try to do some everyday applications. So when we do get a chance, maybe we're playing board games or something like this. We're always trying to do everyday applications for like whatever chance arises.
So learning through play.
Yeah, through play or through just any opportunity really, like for a shop or going out or getting something. There's always examples because I personally don't do a lot of homework with that. So if I get on a weekend or something like that, if I get a chance, I'm really trying to do it, especially through play, board games.
Would you say it's sporadic or would you say
it's
you do
more
something?
sporadic? Yeah. I think Ryan does all the homework.
I don't know how much that is probably selling for him.
Okay, that's fine. Okay, you have something?
Mine was more the attention span, which is 5. Sometimes you get 5 minutes just for that, and sometimes you'll go for an hour, but I don't know if she's getting anything out of it.
Okay, that's fine. Jawad?
For what does home learning looks like for math, I've written repetitive worksheets, we should do table with practical examples like pennies and calories, which I haven't done.
So is a repetitive worksheet as a positive or a negative?
I think that's looking.
Okay.
Yeah, sort of.
It's a lot of repetition basically, road learning.
Working together and separately, so I think kids should be able to work together with your parents just to sort of learn and then go on your own and and attacking yourself.
Yeah.
It should be fun and engaging. And I thought it should be around half an hour a day.
Okay, brilliant, thank you. Can someone share anything they've written in terms of any concerns they have or what you think you could be doing better at home? Anybody?
I think one of the things we're struggling with is just trying to get quite a few things to slot a few things in.
Okay.
Where previously when we were homeschooling, we had a bit of a larger window because we had the morning. Now he's at the Grove from 9 to 12.
So from your perspective, how much time do you think Abdullah should be spending?
Should be.
Yeah. Like you saying, finding the
time
time
to ask that question because I think I'm overcritical about it because I look at periods where he's been able to maintain focus for an hour, say for example.
Wow. Okay.
Comparative to periods where he's only been able to maintain focus for 5-10 minutes. What was your question? Sorry, how long should he?
Yeah. How long do you think Abdullah should be doing that every day? So if you don't.
I think personally half an hour minimum. You know, so I get the concept that you can just do it 10 minutes, 15 minutes.
Yeah.
But it takes 5-10 minutes to engage. Yeah. To get your feet under the table to a point where right, I'm ready to do something. The first 5-10 minutes of that, the pencil's going through the roof, all this kind of stuff, and we're fiddling all that. Once you've got that period settled, you're 5-10 minutes into it already. And then you're now ready to start engaging with let's start doing some learning, and then you have to start sometimes refreshing them on the concept, and then you're 25 minutes into it at that point.
Okay, fair enough. Anybody else? Any concerns or anything that could be doing better?
I've written the previous worksheets, the ones they've completed.
Yeah.
Should we mark it ourselves and tell them, or should we just leave it wrong so the teacher can see?
Okay.
So that or so the teacher knows what needs to be done, because obviously we will know.
So in terms of marking the work that they do,
Yeah.
whether that should be done at home or in the building. Okay, that's fine. Anything else?
I just want to just know whether or not if the example is in line with her stage where she should be at, in that example, knowing if that's okay, is she behind or not at her level.
Yeah, very good. We will show you some examples of where we expect students to be. We have some progression maps that we'll show you, and hopefully that'll give us a better idea of where a year 1 student should be, where year 2 students should be, what kind of things they're covering. I think it's important to know the overview, but we'll talk about that later. Keep those sheets with you for now. We'll collect them at the end. As and when you remember something, just make a note, please.
So just so we know what we're covering today, so we're going to look at what the curriculum does say. So questions about where my child should be, what does progression look like for them, are things that we'll be going over in terms of the coverage of the curriculum. We're going to be looking at specific things in regards to how to support your child, how to build fluency and mastery, and different things that we put together to help support your child in the learning of maths. Again, if it hasn't been signposted already, you have these inside your pack, so feel free to pop them out and take those to the room.
So just there's only one copy per folder, right?
Yes. Yeah. So it's just a generic statement which just rings true. It's the first few years of a child's life are especially important for mathematical development. Research shows that early mathematical knowledge predicts later reading ability and general education and social progress. Conversely, children who start behind in maths, they tend to stay behind in maths throughout their whole education journey. So I can attest to this as a teacher because we see this firsthand. There's never ever been a situation in my teaching career that when I have a child in year 2 who's weak in maths, really weak in maths, by the time they get to year 6 when they come to me, they're strong. Never happens. What normally happens is the trajectory is if they're weak in the beginning, they will stay weak and struggle and plod through, possibly all the way through until secondary school. That sounds really scary, but The scary thing is because they're not getting the support at home, the parents haven't identified that this is an area of weakness, and therefore they're just hoping that one day the penny will drop. But what happens with the child is over the years, they will start learning how to mask the fact that they're not good in maths. They will just become anxious when it comes to maths. They will just have coping mechanisms to deal with the fact that they don't have strong number sense. So this is where I was going to ask a question here, which is, what is your experience with maths? I'm sure in this room we have adults who are once children, who have really positive mathematical experiences, and I'm sure on the opposite side of the spectrum, maths was an issue and an area of anxiety. So just 30 seconds to think, what is your mathematical culture, what is your upbringing when it comes to numeracy, when it comes to maths, when it comes to reasoning, and then we'll get some responses. Okay. Ustad, what's your feeling?
I struggled with maths my whole life. I learned functions and I had no idea why they worked. So I was just operating ones, like just pulling a trigger on a gun, no idea why it works or what it's doing. And anything that became a worded problem, okay, and I had to work through, I wasn't sure which function, which little gizmo I needed to reach for and use in my maths toolkit. You know? So I ended up kind of reverse learning these things after. I'm not sure that it necessarily in work or employment, but when I was doing stuff. If I was doing stuff and I came across a problem, and I was like, okay, I need to figure this out. So I started understanding the actual how and why the function works, what's going on there. And then as I had to rebuild my toolkit, and then I had a more intuitive idea of which thing to reach for and use when and where. But it means that whenever maths comes my way, I'm like a deer in headlights. I just automatically got that anxiety and I'm blind. I have to really, really slow down, have a very pedestrian walkthrough of what I'm doing and why.
Ashraf family?
Yeah, so I never really used to do my homework. I was never really pushed to do any homework.
Yeah.
So in primary school,
Sounds like a confession time. What's going on?
in primary school I was pretty bad at it. As I worked through like after secondary school, I started getting better. I think naturally I started enjoying it.
Yeah.
And now I'm kind of, let's say, I'm average.
Okay.
Yeah.
Kill?
Pretty much the same. I struggle to
Struggle for maths? Asfer, you got a massive smile on your face. Gosh, go on then, Asfer.
You had a maths degree or something, didn't you?
not maths. I used it in engineering at Yale.
Asfer?
Yeah, I was fine up to A levels. I did a computer science degree as well, so we do maths.
So you...
Yeah.
But what's really interesting, because not to take the mic, but you're smiling because it's positive. Anyone who talks about a negative maths, you can see how it's impacted them outside of just the classroom.
No, I think as a child I was good at maths.
So is Musa.
Rubbish at literacy.
Yes, okay.
So 11 plus, yeah, passed, that was easy. Then Herschel, and yeah, that was fine. A levels, I didn't do A level maths, but GCSE I was in the top 7, all that stuff.
Chakra?
I think the consensus is if you had support from your family, from your parents mainly, which I did in terms of making sure homework is done and they know exactly what your results are, you get your parents' evening results and the dad's asking questions to the maths teacher especially. I think it's a Pakistani thing as well generally to be, I don't know, I think a lot of parents are hot on the maths just because they're more comfortable with it. Whereas in English, because it's not their first language usually, they tend to shy away from that. So, yeah, the consensus is that if you have that support from the parents, they're comfortable with teaching and supporting you with that subject, then naturally as a child, you'll be better at it.
Wow.
I think.
No, really good. Anybody else?
It's interesting, we have very opposite experiences when it comes to it. I'm probably a case study of someone that's got PTSD from the maths lessons when I was younger. I still remember my year 3 or year 2, must be year 3 maybe, maths teacher, her name, what she looks like. 10 o'clock in the morning it used to be the maths lesson, and I used to dread it because it probably was just one of the sessions where one of the concepts I just didn't get, and then the next session I didn't get the next concept, and it was just a domino effect. And as a result of that, I built that trauma around maths to the point that I shied away from it as much as I could in my primary years, secondary years as well. I remember doing my 11 plus, seeing certain things and just wanting to brush over it. But what's really interesting is I see some of those connections now in my adult life, in my career, when it comes to certain engineering principles, and I'm having to try and compute certain engineering principles that are fairly mathematical and fairly math driven. And there's people that are around me that are able to make it, and it takes me a lot longer. And I'd probably put that back down to not having that, that
foundation.
yeah, and that brain training from a young age as well.
It's really important having these conversations, because if you can reflect upon this for your own child and making how much we can't lose sight of their foundations, because otherwise this is what happens. Yourself, brother?
Yeah, I'll say we were 3 boys, same age, similar age, and you can definitely see there was a big discrepancy. We all had the same intention. One of us was really good at maths, the middle one. He did his GCSE on his own, 8 or 9.
Wow.
And then he did his A-levels early, and he was just, and he didn't even put a lot of effort in. We were like, what's going on? So we were all put under pressure from our parents, but you can definitely see, like, one of us was always, especially in maths, he was excelling. Now he's an aerospace engineer, so he just loves maths. That's all he does.
Was he good at maths because of the pressure?
We were all pressured.
But were
He
you
was
good at maths
lazy.
because of the pressure?
No, he was lazy, but he was very good.
Naturally
Do
gifted.
you think he was naturally talented?
Yeah.
And do you, at the time, did you feel like you just didn't have that natural talent?
100%, I still don't. 100%. Yeah. Like, I was good at maths, so I was good at, we were pushed really hard. Like, I always get like over 95% and everything, but I was pushed and I put the effort in. He didn't put the effort in. He was just naturally just sitting
No, I
there.
was just thinking, yeah.
I remember the night before his maths GCSE, he was just lying back, chilling out. I'm like, what are you doing? He's like, he went in, he smashed it. Yeah, so I think there's a big discrepancy between children, just generally.
The reason why I asked whether it is because it's forced. So it reminds me of my brother-in-law, my wife's brother. He's like that. He didn't have to put much effort in, and he'll sail through. And I don't know if that was as a result of their father being quite strict on it, or whether a genetic link or whatever it is, or just.
It's so interesting to hear, because there's some people who are naturally really strong, but their challenge comes later on in life because they've never ever been challenged. That when the challenge does come, they can often fall, often not. And the other one is that there's so many examples of us struggling, but ask yourself what support was in place. So we are probably going to find ourselves in a situation, because usually you don't get children who are strong across the board. It's normally maths and writing is like that, or writing and maths is like that, just like you've mentioned for yourself. So the question is, what scaffold, what support are we putting in place to give them the best opportunity in both? So we'll go through that.
Okay,
What
can I just point out one other thing as well?
Go on.
If I'm not mistaken, all the blokes who said that they weren't particularly strong. You've all got a background in STEM of some sort, isn't it? That's professionally what you do. I mean, you're an engineer. I don't think that you're very thingy. But am I right in that? And have any of the women folk got a background in STEM?
Science, technology, engineering, engineering and maths.
Maths, yeah.
Yeah, it was.
Yeah.
Fake it until you make it, possibly. So the national curriculum expectations, I wanted to share this simply because you're probably curious to what the national curriculum says. However, the truth is it's really wordy, so we've left it there for you to refer back to. The only things that we want to highlight is what we've underlined. So fluency, to become fluent. So when you ask a question to your child, they get it just like that. Conceptual understanding, reasoning, so word problems, or understanding what the question is asking, and applying the maths to different routines and different situations in their lives. So that's what the actual national curriculum expectations are. At your children's age of year 1, year 2, times tables is something that's really, we focus really strongly on. And as you know, a child, to be confident in their maths, confidence with their number sense, their times tables needs to be on point. If your times tables are really strong and you have really strong number fact knowledge, then division, which is the most challenging of the 4 operations of addition, subtraction, multiplication, and division becomes really easy as well. So what we always stress is that you really focus and get it right, times tables. And this is where Pakistanis have a huge advantage, because this is where the Ratta style does actually have its place. It doesn't have its place in many places in maths, but in knowing your times tables and drilling them down and having that strong with the children is really important. Also, what some parents do is to get the children to do their 3 times tables. Okay, now you're struggling on your 6 times tables. Oh, your 7's a bit weak, and then they kind of do like that. In school, and research indicates that if you get the children specifically really strong on their 2, 5s, 10s, and square numbers. Anyone want to share what square number is? Asfar, of course. 2 2s are 3 3s are 4 4s are, and it has the little 2 notation. If you get them really strong at this is the amount, everything that's in red is the amount of their times tables that you have covered. So if you think of a square, because by the end of year 6, they need to know their times tables up to 12. That's the expectation. And this is just showcasing that if you focus on the 2 times tables and the 10 times tables and the 5 times tables, which by the way, your children will thoroughly enjoy doing, because these are accessible for all children. They can do their 5, they can do their 10, they can do their 2s. And focus on square numbers, which will make them feel really clever. You've covered a wide breadth. This doesn't mean you don't focus on the rest of the times tables, but you would get these secure first. Does that make sense? Okay? Also, one of the biggest fears when it comes to homeschooling is that you get worksheet heavy. We use counting sticks in school. I really recommend you purchase one. I got this from the Growery to do your times tables. Okay? And I'm just want to showcase with you, you have to participate. This is a really awkward moment for a workshop. You have to participate. And I just want to kind of show how valuable this is. So when you use a counting stick, we all start from 0. So I say this is 0. And it goes up to 10, but because the expectation is for the child to know up to the 12 times table, I always go on like I carry on. But just in case you don't know what I mean, we'll just do it together. So we're going to chant together. MashaAllah, the Growery family chanting together. We're going to start from 0. We're going to do our 2 times table, 2, 4, 6, okay? And we're going to stop at 12. Is that okay? And then you're just going to follow my lead. And I just want you to envisage doing this with your child. And I also, hopefully, you're in a place where if your child has a brother or sister, you can do it together and they really enjoy it. Are you guys ready? Are you excited? We need you excited. Okay, always start from 0, okay?
0.
Wow, that was painful. I would be keeping you in for break, Ustad, because you definitely didn't participate. Okay, let's go. And get your children excited. Okay, ready? Let's go.
0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 26.
Don't expose yourself. Now, we go backwards. So when we say we want it to be drilled, we want it to be drilled forwards, backwards, every left, right, whatever you name it. And also, cognitively, this isn't more difficult. It's only more difficult because we don't practice. We only ever practice going forward, right? How often are you practicing going back? So it doesn't make any difference in terms of the cognitive experience. There shouldn't be. You're only finding it hard because you've never done this. So don't do that with your children. With your children, they should be going back as well. So where were we? 24?
22, 20, 18, 16, 14, 12, 10, 8, 6, 4, 2, 0.
Right, can we go faster, please, class? Because that was really slow. Okay, ready?
0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 19, 20, 22, 24, 25, 18, 16, 12, 10, 8, 6, 4, 2, 0.
Okay, Akil.
What's the question?
You should know what the question is. Good. Waleed.
4.
Jawad.
Is that right?
Yeah.
10.
Jawad.
10.
Stop it.
20.
Get my mic.
Is that when you hit them?
Asfar.
No.
10.
You hit it now.
Okay. Right, now let's go again. We're going to go again. We're going to go from 2, okay?
0.
Can you guys be a bit louder, please? Right.
0, 2, 4, 6, 2.
Okay, you get the point. Okay, go.
0, 2, 4, 2, 4, 6, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 8, 10, 8, 10, 12, 14, 12, 10, 8.
Do you get it? Do you get how valuable that is over, Putter, come home, here's your worksheet that I've downloaded from Twinkle, and do your 2 times table, okay? Do this every day for 10 minutes, and you're laughing, okay? But that's the power of this. When I worked at a school, we had to do this at the beginning of every math lesson. We had to do that. So don't think this is just this is really valuable. If you know your child is struggling, and by the way, at this age, all your children could benefit from this. This cost me £6, okay? And I do it fun. We used to get children to say 0, 2, 4, and they just used to love it. It's really engaging, really exciting. And we're just talking about 2 times table. You could do 5, you could do 10. So just always remember, start from 0. And if you like to stretch your child, because the expectation is that they need to know up to 12, you just add 2. Yeah. I also just get a post-it note and I start placing the post-it note in different places. I also do get them to be quite simple. We'll say 0 and then 4, 8, so that getting them to pause and then speak also helps them to understand it. So that's just something I want to share with you.
I wanted to ask a question on that. So you know that whole style of us doing quite a lot of times. How does that help me working out on the spot what 7 times 2 is?
Why not?
Because haven't I just learnt it just like the order of it? Haven't I just memorized?
No, that wasn't what we were going back, forward, back. All you're trying to do is make your timetable really, really strong, so you have strong recall. What you're talking about is recall. The recall of 7 times 2 is 14 will only happen once you've done this enough times of all the times table. Imagine you do this all the time, every day, back, forward, front, back, and then someone says to you 7 times 5, you know straight away.
I think what Waleed is saying is because it's not marked on there. What we're doing, like 2, 4, 6, we don't know what 6 is. 6 is 3 times 2, but it's not marked 3 times 2 is 6.
Oh, okay, that will come. This is just foundations. It progresses from there. That will start developing your times table further. But the starting point is still the same. The starting point is that they need to recognize. What you're talking about, it will come later when they recognize that 3 times 2 is this and that times 2 is also that, and you mess around with different numbers. But at the foundation, we always start with 2, 5s, 10s. Does that help? So I don't know if you want to add on if you're not understood the people.
No, I mean, when you're doing it randomly, if I go there, the child will automatically think. They may not say 1, 2, 3, 4, 5, 6, but they'll know. Oh, it's 7 times 6, that's 42. But you're right. They need to have it written down as well.
Initially, what they might do is they might literally come and point and count their way through, but they're going through that process in their brain. And what will slowly happen is all of that external will shoot back into the internal. So they'll intuitively just do it.
But this is really good to help them engage with it. It's a fun way of learning. So hopefully, if a child doesn't want to sit down and do lots of worksheets, this is really, really good.
Really protective over my stick. Going to talk about this point. So one of the biggest issues that people have with maths is that it's boring, that they find it boring. So these things, to make things engaging, to make them have a genuine passion for maths, goes a long way. Yeah, and also I just wanted to say, if you find a position where you are giving worksheets, Can you see how this would be supportive to the child? These arrays, they can actually see that 1 times 4 is that. That is actually what 2 times 4 looks like. So don't always be too quick to go to the abstract. So we'll speak about this, but remember, going to the abstract of just in writing is the last thing we do. First we start with the concrete, then we go to the pictorial, then we go to the abstract, okay? Even if you think, yes, but my child is good at maths and he's absolutely smashing the abstract, it still takes away from making them understand what the math is. It's always nice. If you heard of Jerome Bruner, it was his theory that's really excelled, that he takes the CPA approach, concrete, pictorial, and then abstract. Okay?
Okay, so we're just going to show some of the calculations that we got in Key Stage 1, so year 1 and 2. So one of the things that came out, from the feedback that we got from you just now, that some people said they were quite weak at maths, and it could be that they didn't get a lot of support, or the ones who were very good at it, either they're naturally good at maths, and those who perhaps aren't naturally as talented as others, how do they become very good at it? There's a lot of support from family. But the key thing to succeed in maths, and this is what we notice a lot in secondary school, the most important thing is confidence. So if a child is confident, it will help them to engage in the subject. If they're finding it difficult, then they'll try to escape from that work. They won't want to do it. And they'll have those anxieties, apprehensions, whenever there's, maths lesson, they'll dread to go into maths lesson. And that negatively reinforces, that culture, and you don't want to engage with the subject. And it just spirals out of control, and you can't really get very far with maths. And that's where Salmosin mentioned that students who are weak in year 1, 2, 3, they will always stay weak. Okay? Yes, there are exceptional cases. When we get students in year 7, we can, from the baseline assessment, we can have an idea of what kind of grade they will get in maths. 95% of the time, our predictions are pretty accurate. Yes, there are exceptional cases. There are students who never engage with the subject. When they come to year 10, 11, they come to realization of, I need to consciously engage with the subject. And they will do what you call learning to the test. Okay, so there will be a lot of rote learning. They won't have much conceptual understanding, so they don't understand maths. But what they can do is, with lots and lots of practice and discipline, they can do well in a test. They can do that. So how do we build confidence in children? And this is where these manipulatives come into play. So number line, I think that's one of the most important tool that we have, especially in younger years. So you may think that my child can do 5 out of 3 equals to 8, but if they're not able to communicate why that's happening, and that's the difficult bit. And now, since the change of the curriculum in 2017, there's a lot of problem-solving type questions. And somebody mentioned they struggle with wordy questions, or my child finds wordy questions difficult, because there's a lot of problem-solving element and mathematical reasoning element. So how do you build those skills? So students who tend to understand the why, or they can communicate mathematically, they are in a far better position compared to students who've just done rote learning and they've just learned to 5 out of 3 is 8. I mean, this is quite a basic example. So these things, for fluency, they need to know. But if they can understand why it's happening, and that will only happen if you have, you use the concrete and you use the pictorial examples before moving on to abstract. So if I just give the analogy of, let's say, Quran learning, so having spoken to many Quran teachers, they'll say we really focus on qaida. We really focus on, recognizing the letters. And when I was speaking to a few of them, they said, 2 years. And I thought, 2 years, that's a long time just learning qaida. And then they explained that it's very important, because once their foundation is there, then the reading comes very, very easy. So similar in maths, if the foundation, the conceptual understanding is strong, they will be their confidence will grow, and as they become more confident, they will enjoy maths. If they're not confident in maths, the enjoyment won't be there at all. So there are different ways of doing the calculation, and we can get children to go. So if they've learned number bonds, they should know number bonds really well. So how do we get to 10? And we can split 8. So they've done parenthood model already in year 1 and year 2. They can split 8 into 5 and 3, and then how do we get to 10? And then from 10 jump to 15. But they should be able to tell you on a number line how they get into that answer 15. And even if they can do 7 add 8 equals 15, they can recall that because they've memorized it. They should be able to communicate mathematically. That's really, really important for their conceptual understanding. So that's partitioning. So again, 37 add 28. So again, they should know how do we get from 37, how do we add 28 onto that. So partitioning 28 into 20, 5 and 3. So some of these questions, if I ask you to do mentally, a lot of the times you will just end up doing partitioning in your head. Like if I'm doing multiplication, if I'm doing addition with 2-digit numbers or 3-digit numbers, automatically I'll do the partitioning. But that model they need to understand by doing that at a young age. Otherwise, they will always have that anxiety whenever they see a 2-digit number or subtraction or division, because they find it really difficult. Again, 87 add 28. So this is another way of doing it. So again, partitioning, but not using number line. But again, they have learned how to do the partitioning. So 2, 4, 9 add 96. So when they get to something like this, again, they may start adding, 9 tens and then add 6 onto that, and that's more difficult. But you want them to be able to recognize, and you may have to guide them through it, but after a few examples they should be able to pick this up, that when I'm doing 2, 4, 9 add 96, I could just add 100 and then take away 4. But again, that's recognizing 96 is 4 less than 100. But that only comes with practice, lots and lots of practice. But that idea of 96 is 4 less than 100, if they keep doing it on number line, and you don't have to have a number line where it just breaks from 0, 1, 2, 3, you could go from 0, 10, 20, and they should be able to tell you in 96s, for instance. But if you're adding 96, but if they can recognize 96 is, for instance, if that's 100, that's 0, I'm not going to split that's 90. If they can tell you this is 96, and they should be able to recognize, but by doing this, eventually they will understand, oh, that's only 4 less than 100, okay? Otherwise, they don't pick up on these things, and they only come with lots and lots of practice. This is why using a number line, having a number line is really important. This is a math, oh, they do have a number line there. Like in every classroom, we have number line in front of on top of the board.
And in primary school, we have to have the number line. We have to, it's the rules of the classroom.
Yeah. And again, if they can do this in their head, that's great, but still take them back to basics, especially in year 1 and 2, because it will really help them in the long run.
I was going to ask, you know that calculation of 87 plus 28
yeah.
you had on the previous slide as well. This method here, is it a progression from the previous one, or is it an option of
Yeah, this is a progression.
Progression.
Because number line, that's like the very basic.
I was just thinking of that 37 plus 28 equals. I don't think we've ever conceptualized it in that way, haven't we? As in like adding the 20 plus the 5 plus the 3.
But he may be doing that in his head.
Covers it, but then if you didn't get it, so we just didn't focus too much on it.
But I would take him back to this, because later on, we'll look at some multiplication examples as well.
And also, just rationally, a child would probably find this more accessible than the other one. Because the other one just turned, this is actually the math taking place. The other one is like a process. You're going to take this, add that. Do you get it? And the child remembers the process. This is actually explaining the math that you're actually
understand
The conceptual understanding is the key. And this is why taking your time at this stage is fine. And that's why number sense, first 2 years, you just need to build their number sense. Everything else about maths is not as important, it's number sense. And if they have strong number sense, they'll be very confident.
Can I just ask? So what you've mentioned is literally what parents do. They would see the other approach. The child could do the other approach, which seems difficult, and then they just crack on because he can do it. But if the child doesn't understand this, there may come a point where they just get caught out because they haven't actually understood the math. They've just understood the process. So we always need to go back to the conceptual understanding because that would help them in the long run.
Yeah. And it's not just for these calculations, for many other areas of maths. That skill they need to use. Okay, we did all of this. So again, subtraction again. They've started from 77, so you can do this on number 9. They're just going backwards now. And they'll go backwards in 10, 10 and 5. And they should be able to take away and add 10s very comfortably at this stage. Okay, multiplication. And again, emphasizing to them that multiplication is repeated addition. Okay, children don't understand this concept that multiplication is a repeated addition. So 5 times 3, so that means I could have 5 3s or 3 5s, it's the same thing. And it's associative, so the order doesn't matter. But they do get those ideas later on anyway, but we can emphasize it to them. Let's do some more. So 14 times 6, again, some students, they'll just learn the timetable, so 14 times 6, 84, they'll just know that straight away. But if I change that to 40 times 62, for instance, okay? Now, when reading 14 times 62, some of us here probably can do that very quickly in our head, but we don't know 62 times table, or we certainly don't know 14 times table up to 62, but we're doing partitioning in our head. And that's what they're doing here, that's what is going through our head. But some students just cannot do that because they're not used to doing the partitioning. And that's why, and to build the speed, they have to practice that. And that's when they're doing the assessments. Let's say we'll go through some questions that they ask in SATs as well. That speed will only come if they're used to doing this method. Otherwise, learning the other process, it's more time consuming and they can't really check the answer. This also helps you figure out, am I going the right way or not? Here's a wordy question as well. Do we have any more? Oh, so this is, sorry, they're not related. So this is a very straightforward SATs question. So SATs used to be end of year 2. They don't have SATs anymore in year 2. It's all in year 6 now. But just to give you an example, somebody asked, how do I know which stage my child is supposed to be? So I think they have 2 SATs papers, one arithmetic, so they'll have questions like this. But this is what a lot of students struggle with. The reason why they struggle with wordy question, one, comprehension, so they can't break down the problem. And second, they just don't have those problem solving skills. So it's difficult for them to be able to answer those type of questions. So they, even though it might be a very straightforward question and they should be able to answer it, they just don't engage with it. Okay? If they've not done questions of that type and they haven't developed mathematical reasoning skills.
What year is that question for normally?
End of year 2.
End of year 2.
Wow.
So Abdullah should be able to.
By end of year 2.
End of year 2, yeah.
Well, I thought it was end of Key Stage 1, which is year 6, isn't it?
Key Stage 1 is end of year 2.
Key stage 1 is year 1 and 2.
Oh,
Key stage 2 is 3, 4, 5 and 6.
Could you read the question? So
the question, Alexa is 7 years old, Sarah is double her age, and John is 3 times the age of Sarah. What is the age of John? So you will have students in year 9, year 10, if you give them these questions, some of them will struggle with that type of question. And it's the first reaction they have when they read a question like that, they just become anxious. They start panicking. And even though they may have all the tools in their toolkit to be able to answer that question, but they just don't engage with it. Because they've not been exposed to those type of questions, or every time they've been exposed to it, they'll take a guess. they don't make a conscious effort to answer that question.
Sorry, you know the 17 plus 48, is that?
Separate
No,
question.
Okay, yeah.
The example.
one type of question, that's a different type of question. So again, with multiplication, it doesn't matter which method you use, but again, go back to the partitioning, start from there. Then some of you may have learned the grid method when you were in school. So again, partitioning, but some students find this really useful. And some of you may have just learned column method, that's not here. But again, we don't really emphasize on column multiplication, especially in Key Stage 1. We don't really want them to do that. Okay. I think that's the next page. Oh yes.
So, did you say you don't emphasize the column method? We do.
No, we don't really tend to. Do we do column method multiplication? No. Not in year 1 or 2. Again, some parents will do that because they themselves find that easier, or that's the only method they know. But the point we're trying to emphasize is teach them the partitioning. Okay? Well, they've learned that, they should be able to do that. And mentally, when you're doing these questions, in your head 37 times 8, they know what 3 times 8 is, so they should know the place value. Again, place value is a big component in year 1 and 2. So if they understand place value, they should know that talk about 3 tens. So 3 tens, so 8 times 3 tens, so 8 times 30, they should be able to do that in their head, 240. And 7 times 8, they know, but they just need to know how to join those two. Okay? So that's what we need to emphasize in year 1 and 2. It's just building those foundations. Parents find column method multiplication easier because that's what they're comfortable with, and then they don't know how to explain to a child, and it's a very difficult thing to explain to a child why we're carrying 1 over, or why we're borrowing 1 when we talk about subtraction, for instance, because those concepts are not very easy for a child to understand unless you teach them through the manipulatives or you use number line, because then they can understand it.
One of the things to be careful of as well is the column method might seem more intuitive to us because that is the method we know. But we have a big blind spot. We forget the whole many years of all that process of learning that method. So when we're coming to our kids, we're just assuming they're starting at the end of that process. And we don't remember in year 1 exactly what we were doing or how we built up to knowing that and being more comfortable and familiar with that.
But but the possible reality is that we didn't have a great experience, and when it came to doing a test, we were just taught this method, and this method made sense because you just got to. So it's almost like you were missing the foundation. We've missed the foundation blocks ourselves, and that's like. I remember when I did the reading workshop, and I said, "Oh, when we teach our children big, amazing words, but they can only ever use that word in that context." It's similarly with this. You teach a child this because you're like, look, mashallah, my child did 37 times 8. But really, all what they did was follow a process. The math was missing. And that's what we're trying to avoid for your children. All I'd like to do now, there's a lot of conversation about manipulatives, things to help us and our children learn. I've got an array of manipulatives out on your tables. What I would just like you to do is have a look at them, go around to the other tables because there's many of them, and just ask yourself or speak to the person next to you, how would these help our children, okay? Off you go. I think it's one of the points here are that almost all the areas of maths, they have manipulatives to support. And at year 1, year 2, when at school when I do a learning walk and walk into people's classrooms, if there's not manipulatives out in a maths lesson, that's a huge panic for the leadership team. They're like, why is this the case? How are you having a maths lesson and don't have manipulatives out to support your children? So all of this is just from one classroom. I didn't have to go around the whole school. I just got this from one classroom, and manipulatives are used religiously. So again, it's a reflective point that when we're doing maths, are we too quick to jump to the abstract, as it probably was in our own experiences, or are we going through giving them physical, tangible objects, showing them pictures, and going through some sort of process to help them understand what's going on? this slide here, the next two slides, I just wanted to show you what your child's learning should look like through the academic year. So they've done place value and addition and subtraction, and hopefully towards the end of this academic year, we should cover most or many of these things. Of course, as parents, it's good for you to have an understanding of where your child's learning is going, and it's also good for you. In school, we always have parents who want to know, what is my child supposed to be doing next? What they're going to be doing next term? So here, this is for year 1 and for year 2. You just have an understanding of what the learning is going to look like for your child this year. So this is just
year 2. That's year 1.
Year 1, year 2. Yeah. So I just wanted to show this to you so you can have an understanding. Of course, being a 3-hour provision, we have to bear in mind that for us at the Growery to go through all of this is going to be an impossible task. So this is where, as co-teachers, we need to take some ownership to make sure that our children are progressing through. However, as you can see, as Saad's made point, place value, number, place value, number, place value, number, place value. The entire year focus, more or less, is on number sense, is on understanding the 4 operations, understanding partitioning. All these other things about fractions and time and mass and volume, length and height, really genuinely not important at this stage. All that stuff will come later. This will be a real struggle if they don't have good understanding of place value and not good understanding of the 4 operations. Same with writing. When we teach writing, we just say, focus on the bare foundations. We teach the foundations all the way up until year 4. Capital letter, full stop, finger space, legible handwriting, cohesive sentences, verb agreement. Just very basic things. And then at year 4, then we start to get really creative. Same with the math. Got to really get those foundations strong, so that for the rest of the journey in the mathematical journey, it doesn't become a struggle. Break time, mashallah. You're going to have a dedicated 5 minutes. Grab yourself something to eat, drink, and then we'll carry on, inshallah.